Hello, I'm Clinton Garwood. Thank you for letting me present my research into technology that could be used to enhance learning. A learning app, in this context, is being defined as a sensory-enabled environment. To simplify this is a traditional learning environment, which has a person and a computer, and this is a sensory-enabled learning environment. You'll notice the difference is the sensor, and there are all kinds of sensors and multiple types of learning environments. This presentation focuses on adding a sensor or sensors into a learning environment to improve learning outcomes. Why? Well, sensors read all of this. Let's look at this list. On the first line we see creature movements, and this is us clicking on or touching objects in the virtual space. In addition to touching things, we can also track passage of space and time, and we have physics tools. Verbal commands are measured in intensity and also can be interpreted for user sentiment and meaning. Proximity sensors provide face recognition capabilities, and we also find behavior being a topic of study. If you think about that list, these are the same feedback clues a teacher reads when working with a student: what they say, what they select, and how they otherwise react to incoming data. We know that teaching and learning are sensory-driven experiences. In learning, a student is broadcasting their response to incoming data. In teaching, a teacher is trying to read and analyze the student's reactions. The addition of technology, sensors in this case, to any learning environment can produce a positive effect for the learner and the teacher. So, how does capturing the gestures of a student affect learning? Well, we know from life and society what certain facial expressions mean. Each expression contains social and semantic meaning. We recognize these expressions on our students' faces. But real life comes at you fast. Sensor technology can feed us frame-by-frame data, which we can parse with facial recognition and object tracking software. We add time-based analysis in to determine a learner's sentiment. The software then can be trained to look for any behavior and also programmed to motivate, support, and encourage the student. An object-oriented programming paradigm fits well in here. Let's zoom in on an example to see how this will work. A student is asked a question. The software listens to the response, and if the student is confused, a learning resource is fed to the student to help them understand the concept. After the exposure to the resource, the student can then again be quizzed about the information. If the student has been educated, the next question can be presented. If not, another presentation of the concept can be offered. Teachers do this every day with every student in the classroom. Adding sensors can help teachers make sure the proper level of detail is provided to each student. And sensors can also handle a crowd. One-on-one, it's easy to read personal and nonverbal cues and respond based on the signals we get from users. With two, you get more than double the work because of social dynamics. And with three or more, it leads to less personal interactions with students. With sensors, we produce a very personalized experience and can scale to crowd size just by adding more sensors. In group settings, we have the opportunity to spot anomalies in sensory zones. Sensors give us very personalized data from each user, and we can use that to create a high-value, high-reward learning environment. Sensors give us a mean to respond to every student at all times, and as the class size grows, we can turn to the cloud for support. So how would we get this system turned on? Well, sensors are obviously needed. These are already embedded in phones and other mobile devices, including wearables. Game consoles are sensor-laden environments, as are VR rigs. Sensors can be added to any environment by plugging them into a computer that has supporting software installed. Sensory data can also be obtained by analyzing a live or recorded video or audio feed. We leave the full product review as a task to be accomplished at a later date. We are going to focus on the big components of using the sensors. These are the big categories for sensory technology and will define the stack we need to leverage. This list was mentioned earlier, and now the references will be presented. So we start with user interaction technology. We have Unity as an example development environment and its GUI API. In Unity, for example, a button is a GUI element, and we can click on a button. We also have tools like physics, rigid body, and we can also script interactions. Next, we have the ability to track a user in motion. Unity provides events so we can understand the movement of a user. We can listen for custom events, and we can detect starting and stopping, changes in speed and turn events, and we can determine a user's location based off of multiple references. Moving into gesture technology, we find that the technology here is more graphically appealing to users, and the tools we have to track hand and facial recognition. We see here some capabilities of the library by Leap Motion to detect and record hand motion. Using APIs can produce a high-quality interactive experience. And gesture technology is an area that is ripe for growth, and some of the most cutting-edge technologies can be found in recent patent filings. Up next is voice sensor technology. We see big names in here like AT&T and Google, and even Mozilla, which people most often know as the Firefox browser. We also see Microsoft Voice and Amazon's Alexa Voice in this category. We also have user sentiment analysis, and this of course relates to the contextual meaning of a user's response. Here again, we find a few dominant players, with Google Sentiment Analysis and Microsoft out front. But we can also find open source sentiment analysis. This is an example using Python. Next is object and user tracking. OpenCV is a library that provides frame-by-frame object tracking for video feeds. We see open source technology again and again in this area, and it's a good resource for educational learning applications. We also have face recognition libraries, which provide us with the ability to track expressions from users, and to create presentations where we can paint a facial expression onto an avatar or an on-screen character. Finally, we have behavior recognition and analysis as a service, which is already starting to peek through for use in laboratories and research facilities. To summarize, the technology needed to produce a sensory-enabled learning environment exists today, and an opportunity exists to use this transformative technology in the classroom. Thank you.